My name is Björn Gottschall and I will present to you T, time proportional event analysis. When doing performance profiling, one needs to go through several questions to identify and solve performance problems. First, how much time does it take to execute my application? Next, where does my application spend most of the time executing? For example, which function consumes most of the runtime? Or in the most detail, which are the most performance critical instructions? But knowing only the most performance critical instructions does not help much, without knowing why. Which poses the final question, what microarchitectural events are the cause of performance loss? T, time proportional event analysis, answers all of these questions. Performance profilers such as Perf, Intel PEPs or AMD IBS have been around for a long time. Most performance profilers break down the execution time across applications and their functions. Many can even break it down onto instructions. Some performance profilers can record performance events to count them during the execution of an application, or attribute performance events to the executing instructions that are causing them. T is able to capture all of this information in a single run with negligible overhead. Time proportional event analysis is the first unified performance analyzer. It creates per instruction cycle stacks like seen in the example on the right, in which it breaks down the instruction execution time across performance events and their combinations, making it easy to identify the exact reasons for the runtime of an instruction. T provides negligible hardware overhead of only 249 bits and 3.2 milliwatt per core, and a 1.1% runtime overhead comparable to the other hardware-assisted performance profilers. We have developed a golden reference that accounts for every single cycle, event, and dynamic instruction, which shows that T is accurate and provides a very low performance analysis error of 2.1%, compared to the average 55.7% of the front-end tagging profilers AMD IBS, ARM SPE, and IBM RAS. When looking at the per instruction cycle stacks of the most performance critical instruction in spec B waves created from different profilers, we can see that T matches the golden reference very closely, while the front-end tagging profilers systematically misattributed time to the wrong events and instructions. Using T, we were able to identify and mitigate performance problems in 2 spec benchmarks, while other profilers gave us no hint at the root cause of performance loss. We sped up NAP by 124% by optimizing the inefficient utilization of the floating point pipeline, and sped up LBM by 28% by inserting targeted software prefetches. Are you interested in more details? Then read our paper or join our talk on Tuesday 9 AM in the Best Papers session.